We hear all the time about how AI is changing our world, but today we're diving into something even bigger, how it's changing science itself. We're going to follow the journey from code to cures and see how this technology is literally rewriting the future of discovery. So, the big question on the table is this: how is artificial intelligence really changing the way we do science? And it's not just about getting answers faster anymore. It's about totally transforming how we even ask the questions in the first place. Now, you might think, okay, if AI is going to write all our code, then our human skills are going to matter less, right? Well, what's so fascinating is that it seems like the exact opposite is true. The main takeaway here is that to really get the most out of AI, you have to be a master of the basics. It's the human who has those strong fundamentals who can really steer this incredible new tool. So let's kick things off with Act 1, the scientist's new toolkit. We're going to look at the skills and honestly the mindset that's defining this brand new age of discovery. Think about it like this. An AI copilot can absolutely help you fly the plane, but you still need an expert pilot in the cockpit, right? Someone who gets aerodynamics, navigation, the whole system. Well, it's the same in science. AI can spit out code, but it's the scientist with that deep understanding of logic and design who makes sure that code is actually asking the right questions and giving us results we can trust. So what does that actually look like day to day? Well, it really boils down to a few key things: following a clear logical design, making sure you're meeting established standards, and, this is crucial, using tools that make your work reproducible. A perfect example is a tool called renv. It basically just bundles up a project's entire digital world so that another scientist, or heck, even another AI, can get the exact same result years from now. And that reproducibility, that's the absolute bedrock of good science. Which brings us right into Act 2. See, with this new toolkit, scientists aren't just making their methods a little better. They're using them to decode the very secrets of life itself. And this is where that solid, well-written code just comes alive. It's the key that unlocks these profound insights into biology. So let's take a quick look at 3 recent studies that show exactly how this works. First up, our first discovery takes us deep into the microscopic universe that's happening inside our own bodies. An international team of scientists has taken on this massive, monumental task, mapping every single type of human cell. This project, which involves heavy hitters like Harvard and the Chan Zuckerberg Initiative, it's a huge shift in thinking. It's not just about collecting more and more data anymore. It's about weaving all that data together into actual usable knowledge. We're moving from just having a list of the body's parts to creating this detailed, interactive map that shows how it all works in concert. I mean, this could completely change how we understand health and disease. Okay, next discovery. This one might just change how you think about your emotions. It turns out the secret origin of your mood might be hiding somewhere you'd never expect: your gut. And this study is just brilliant because it shows the slow, subtle influence these systems have on us. Researchers tracked kids for years and found this incredible chain of events. So by age 2, a kid's unique community of gut bacteria is basically set. Then that composition goes on to influence how their brain networks develop by age 6, which, in turn, indirectly affects their emotional state by the time they're 7.5. It's an amazing look at the gut-brain connection in action. And our last discovery offers a real glimmer of hope for one of the biggest challenges we face with aging. A new study is showing we might have a powerful way to not just predict, but maybe even reverse frailty in older adults. The secret was this metric called EGDR. It's really just a simple score that shows how well your body is managing its energy. And what they found was that a higher EGDR wasn't just linked to a lower risk of becoming frail, it was also linked to a higher chance of reversing frailty that was already there. Now, here's why that's such a game changer. EGDR is easy to measure in any clinic. It could become a standard way to spot seniors who are at risk and get them help early. Okay, so we've seen the skills, we've seen the amazing discoveries. For our final act, let's zoom out and look at the bigger picture: the infrastructure, the platforms, the resources that are helping to speed up this whole cycle of innovation. Now, to get this next part, we first have to understand a really powerful statistical trick called a network meta-analysis. Put simply, it's a clever way for researchers to compare, say, dozens of different treatments for disease all at once. It pieces together evidence from lots of different studies to figure out which options are truly the best, even if they were never tested head-to-head. So there's this tool called Cinema that takes that idea and runs with it. It's a web app that helps scientists figure out how confident they should be in these big, complex analyses. It just pulls in all the data, checks it against 6 key areas where things could go wrong, and then boom, it spits out a simple rating. It's all about building trust in the science. And it's not just the analysis tools that are getting faster. The way we share science is being totally upended. I mean, compare the old way, slow, expensive journals, to these new preprint platforms. They're making science faster, more open, and way more collaborative than it's ever been. But you can have all the best tools and platforms in the world, and they don't mean a thing without brilliant people using them. Real progress also means we have to invest directly in those curious minds who are out there pushing the boundaries. This number, 139. This represents the number of scientists now being supported by the new Cornerstone Investigators Project. This is a huge 10-year program giving stable, long-term funding so that top scientists can go after those fundamental, high-risk, high-reward ideas. And this idea of empowerment just keeps popping up. You see it with places like the Allen Institute, which shares these massive open data sets about the brain, or with tools like Grade Pro that help turn evidence into clinical guidelines you can trust. The core idea running through all of it is simple. When you give everyone access to the best data and the best tools, you accelerate discovery for all of us. So, as we pull all these pieces together, the strong fundamentals, the powerful AI partners, the amazing breakthroughs, and this new, open, collaborative way of working, what we're left with is really an invitation. And it leaves us with this one final, crucial question. With open data and AI partners making the tools of discovery available to more people than ever, who gets to be a scientist now? The lines are blurring, the door is opening for new voices and new ideas to come into the field. The future of science isn't just about what we'll discover, it's about who gets to do the discovering.